Welcome to The Explainer. Today, we are diving into a surprisingly simple rule that, believe it or not, powers everything from Google's search results to the predictive text on your phone. It's an incredible idea that helps us find order in chaos, and it's called a Markov chain. So let's just jump right in with a big question. What if you could predict what's going to happen next, but you could only use information about what's happening right now? What if the past just didn't matter at all? Well, that idea is the absolute core of something called the Markov Property. The easiest way to think about it is memorylessness. It's this rule that says for certain systems, our best guess about the future depends only on where we are in the present, not the whole long history of how we got there. To put it another way, the past is completely irrelevant. Every single step that led to this moment is forgotten. For the very next step, the only thing that matters is where you are right now. And that simple rule has some absolutely huge implications. Okay, so to really get this, we need to see how this whole memoryless idea actually works. It turns out forgetting the past is exactly what allows us to build these incredibly powerful models of the future. Let's look at two really simple scenarios to see the difference. Flipping a coin over and over, that's a perfect Markov process. The chance of getting heads is always 50-50. It doesn't matter if you just got 10 heads in a row, the odds for the next flip don't change. But drawing coins from a purse, that process has a memory. If you've already pulled out all the quarters, the probability of drawing another one is 0. The future totally depends on the past. This whole idea was really formalized back in 1906 by a Russian mathematician named Andrei Markov. And what's interesting is, he was trying to prove that major mathematical laws could still work even if events weren't totally independent of each other. For his proof, he did something kind of cool. He analyzed the sequence of vowels and consonants in a famous poem, Eugene Onegin, and showed how patterns could emerge in a system that had only a very limited memory. So how does this actually work in practice? How do we build a model out of this idea? Let's break down the mechanics, the nuts and bolts of it all. A famous and honestly, a wonderfully simple way to get a handle on a Markov chain is through something called a random walk, or as it's often called, the Drunkard's walk. Just imagine someone walking along a numbered line, taking one step at a time, completely at random.
Okay, so every Markov chain, no matter how complicated, has 3 key ingredients. First, you've got the states. These are all the possible situations or locations. In our example, it's just the numbered spots on the line. Then you've got the transitions, which are the allowed moves between those states. Here, it's just one step left or one step right. And finally, you have the probabilities of making each of those moves.
And this is where you really see that memoryless property in action. If our random walker is standing on position 5, the odds of moving to 4 are 50%, and the odds of moving to 6 are 50%. It makes zero difference how they got to position 5. The past is just gone. Only the current state matters. Now, when you have a set number of states, you can put all these rules into a table called a transition matrix. You can really just think of it as the rulebook, or the engine that drives the whole chain's behavior. Once you've defined your states and this matrix, you can just set the system in motion and see what happens. Now, I know this might all seem a bit abstract, but here's where it gets really cool. This idea is secretly powering the world all around us. So let's take a look at where these chains actually show up in the wild. One of the most famous applications ever is Google's original PageRank algorithm. It basically modeled a random surfer just clicking around the internet. A page's rank was simply the long-term probability of that random surfer ending up on that page. The entire web was one massive Markov chain, with every single web page being a state. You also see this magic every single day on your phone. It's the secret behind predictive text. These systems analyze massive amounts of text to build their rulebook, their transition matrix. The current state is the word you just typed, and the system then calculates the probability of what the next word is most likely to be. It's why its suggestions are often so uncannily good. But the applications are just incredibly diverse. Economists use them to model switches between recession and growth. Biologists use them to model how DNA evolves. They are absolutely essential for speech recognition, for optimizing call centers and data networks, and they're even used for composing music. Yeah, even in a creative field like music, Markov chains can generate new melodies. A composer can analyze a bunch of existing pieces and build a transition matrix. So, for example, if the last note played was an A, there might be a 60% chance the next one is a C sharp. This creates music that actually feels structured and patterned, not just totally random. So, after all of that, what's the big takeaway? What does this mathematical tool really tell us about the world we live in?
The real power of a Markov chain is its ability to take these really complex, seemingly random systems and describe them using a very simple, memoryless rule. The underlying probability of getting from one state to the next can be super straightforward, even when the behavior of the whole system looks incredibly complex.
So at the end of the day, this elegant tool doesn't get rid of randomness. It helps us find the order that's hidden inside of it. It gives us a handle on the unpredictable just by focusing on the probabilities of right now. And that brings us to a final thought to take with you. Now that you know the rule that sometimes the future only depends on the present, think about the world around you. The weather, your daily commute, your social media feed. What else in your world might just be a chain of probabilities, just waiting to be understood?